Good day, everybody. My name is Werner Heijstek. Thanks for the introduction, Annie. I'm here with my colleague, Yannis Kananopoulos. I've spent the last 25 years helping various different types of organizations around the world transform their software landscapes to get more value and productivity from their software and to manage risk. Spent the majority of that time with telecom organizations around the world. And Yannis has a very similar background. Yannis?
Good morning, Werner. Good morning, Annie. Thank you for the introduction. I am impressed by the fluency of pronouncing my surname. Thank you both. You're doing great. It's a typical long surname, Greek surname, plus the Yang is also a typical Greek name. So yes, Werner, indeed, we have similar, let's say, experiences and background. I think I've been helping organizations for a bit less, 20 years or so. Nowadays also we work extensively with telecoms. And one thing that we see is the relevance of AI in their operations or in their software engineering practices. So I look forward for our discussion today.
Yeah, I distinctly in the earlier days of working with telecom organizations that everything was outsourced. I mean that really changed. Also that when we had to do analysis of software systems, and we would also ask, should we look at security? And then our clients at the telcos would say, security, why would you look at that? This is maybe 12 years ago still was actual conversation. This of course really changed. And I think AI adds yet another interesting angle to the conversation. I think it's on the one hand very new, and on the other hand, not at all. And I think that will be a little bit the theme of the conversation that we'll be having. I'm very curious about your experiences. I think it's interesting to note also that we're talking about infrastructure in telecom. So without that infrastructure, AI would not work. And at the other hand, it actually we will need AI to transform that infrastructure. So it's an interesting sort of symbiotic relationship.
Yes, indeed.
But first things first, I think we all agree that telcos are betting big on AI. I would say almost 100% of executives, I think some studies are 97% or in that range, are either already piloting or implementing AI. We also know not everything is immediately leading to benefit, right? But first of all, what do you think is driving this level of adoption?
I think there are several factors, not just one. First of all, the first factor is, let's say, competition. Everybody says we're using AI, so it's important that they can catch up with the competition. The other is customer experience. So we want to utilize AI to make the experience with our customers. Can you hear me clearly? Because I
do. Yes, I can hear you. Yes.
And I think also we talk about cost optimizations, cost effectiveness. Organizations, they want to, let's say, transform internally and become more flexible and more business driven. And when it comes to software engineering itself, I think that telecoms inherently, they want to be on the forward of technology and be seen as innovative organizations. So it comes with the territory.
Yes. Do you? And so there's great promise. Yet the practical benefits to be had are it's not so clear. So we see that there some benefits will be had, but we don't see them had everywhere. Do you see some examples already coming to fruition?
Okay, that's a good question. I'm a bit of heretic when it comes to the Gen AI, let's say, technology. I think that currently what we see is individuals are reaping the benefits of the Gen AI technology, not teams and not organizations. So as an individual, I can use any kind of tooling, a coding copilot or ChatGPT to write an article, and I can get, let's say, great results, of course, always with the proper guardrails and reviews and so on. We haven't seen yet teams capitalizing on this, and it remains to be seen. What we see, although, is that organizations start investing also in more traditional, let's say, AI, so more machine learning models, deep learning models, and they already kind of being operational in marketing or HR or this kind of departments. We've seen some successful deployments of Gen AI, but for very specific tasks, not for something really big. So We have a team of engineers that maintaining a certain type of antennas. We have the manuals of those antennas. We use Gen AI tooling to facilitate the access to the information from those manuals. It works nicely. But it is a very specific use case. It's not something that covers several departments or several use cases. So with one shot, we want to kill many birds. In the cases that we try to build something that fits every department of the organization, usually it doesn't work.
It seems a bit in line, or very much in line with Susan White's talk, the keynote before. It was a very interesting talk, where you should not make the objectives too large because it has too many downsides at this moment. I think also an interesting thing that I took away from that talk is the centrality of the platform, the key and all its requirements. So it's security, observability, and there were many more of these sort of non-functional requirements that you have there. Maybe if we step back and we look at two ways of using AI: building AI systems, where you somehow build your own or build something around your own where you reap some benefits, or using AI. Let's first do the first one.
Okay.
What is an AI system? What is it? And what's that image? There's a beautiful outline in the previous keynote. So what's underneath? What is that platform?
Oh, okay. I'm trying to find a very simplistic way to describe it. I think that an AI system, in comparison with the traditional software system, relies more on probabilities. So we can say that it's more probabilistic, less than deterministic. So if I have, let's say, if I have a billing system in a telecoms organization, the way as a client, the way my bills and my invoices are being calculated, it's pretty fixed. And all the logic is coded it's somewhere in the code implemented. So might be ifs, force, but it's very deterministic. But on the other hand, if a telecoms organization wants to assess my credibility or my credit worth, my credit scoring, or if they want to predict if I'm going to churn, be part of the churn for the next year or next month, then we use more probabilistic models. So the logic behind the decision is not implemented in source code. A certain level of that decision is being made by probabilities by the model.
Yeah.
And that's, I'm trying to be very as simplistic as possible. So this second type of systems, we start going AI. Now, if we look also on the regulations, like EU AI Act, they have more concrete definitions that companies can use. Still there are some gray lines. So what about the good old machine learning data mining techniques like near regression? The kinds of, is this AI or it's not? So legislation, they leave a gray area there. So it's open for interpretation. But definitely we can say a deep learning model is an AI system, or Gen AI, it's an AI.
Now, neither one of us built.
But sorry, one thing that it's important to say is that for when it comes to the non-functionals, the challenge now for the organizations is to define those criteria behind the non-functional requirements that are going to measure the quality, the non-functional quality of an AI system. And that's a very interesting field to be right now.
Yes. Yeah, so I was going to say, neither one of us builds these systems or sell these systems. So what we do is we're specialized in having an opinion on how these systems are constructed. So it's about testing. It's about there are a million different ways to build the same functionality, and we figured out it really matters which way you pick. This is going to be far more expensive, or you need more people and more time to make changes. So what you want is systems that are easy to change, low risk, and that you can actually can then be faster with them. For example, your competitor. And so when you are called, as you are many times, evaluate data sets, AI systems, what do you look at? What are key things that you look at? Is this going well? Is this being done in the way?
Okay. Let's say we start from the data that the system utilizes. Usually we ask for the training data or data set or the testing data set in order to see let's say, how this is, let's say, constructed, whether it abides to the problem. And then we need some access to the model to run some tests to give more insights to the team. The tests might be relevant for the performance/accuracy of the model. They can be in cases of systems that we use demographics. We check for bias. We also generate explanations to see if the model checks things in the proper way. There are several techniques. Let's say the focus is data and the model for validating an AI system in a more concrete way.
Yes.
The other part is the source code and the architecture, because the logic is one thing, it's crucial, but also it is very important to see how the system is architected and what does the source code around it do? What is the quality? Because we see, probably you've seen it as well, that, and we have some reports also as SIG backing up the arguments that data scientists are not prone in writing code that is maintainable or future-proof. So
It's a bit counterintuitive
yeah.
to me. So you said you're starting to get into the territory that you see some challenges there. I would expect these are new systems, right? You also often have large amounts of, especially in the larger telcos, large amounts of legacy systems that are very hard to get rid of. So now we're building new stuff with these AI systems. I would expect this to be much better, right? Because it's
Me too. Me
new
too.
technologies. Is that what you see in practice?
Yes, what we see in practice is that teams they are more informed than like they were 20 years ago about the best practices in coding, testing, and so forth. But still, the eternal business pressure for deploying something as fast as possible to production is the main, let's say, driver. So we've seen teams cutting corners because they are, in a certain hurry to make a deadline, to make it to a deadline, and so forth. And that, of course, means creation of technical debt, means cutting corners, means that if we want to revisit this code and see how we can extend it or how we can fix things, it becomes more difficult.
And this is inherent because it's new, right? So you need to play with this. We're talking pilots. So why don't I just start building very quickly instead of spending a lot of time up front of getting it right? Yeah, why not just make it very quickly to market, see if it works, fail, and continue? Or why not just use this approach with AI?
Oh my God, yes, there are several reasons. Let's just say that personally, I think that AI systems make more critical decisions for clients, for consumers, for the organization itself. So if something goes wrong, it goes wrong at scale. So imagine, let's say, a predictive maintenance algorithm, right? I want to deploy it as fast as possible to see what kind of antennas they need maintenance. And it goes wrong completely. And it goes at scale. So if I have 15,000 antennas and the predictions are wrong, imagine what can happen. So this is for me the first reason, the damage at scale that can be as a consequence of not a careful or meticulous design of my system. The second, which is also very important, is I built an AI system for fulfilling a business case. Might be return on investment, might be cost effectiveness, might be some other reasons. So a system that is not working properly doesn't fulfill the business case. And also this is the report from MIT that indicating that 95% of all pilot projects are not fulfilling the business case. The third reason, which is quite relevant for the board of directors usually, is the risk factor or the risk of being public news that something didn't go well, and then you see your name on the newspapers and people talking about your organization in a very negative way. I would say these are the three main reasons that organizations need to take into account when designing and building an AI system. We don't want that.
This last point rings very true with me that first we start talking about whether systems are deterministic or not, and the second sense we talk about the board of directors. And you see in the olden days, software was this thing that happened somewhere, often at another company. And I think now more and more organizations realize that the link between what you decide on the software level and the boardroom in terms of security vulnerabilities, but even if you leak data, that can be very problematic in certain circumstances, or in most circumstances. It's very real problems, and there are actually a slew more that you can avoid. And I think typically building an AI system well is cheaper than building it not so well. Yesterday I read about the notion of AI debt. It's a very
right. Oh my God.
specifically, not doing it so well the first time around. So
there is debt in everything.
Yeah.
I'd like to say that unlike source code, data is socially constructed.
Mm,
Data reflects patterns, reflects behaviors.
yes.
And the other thing I'd like to say to our clients is that if you build an AI system, let's say you don't need to pay attention only to the source code because the data themselves are part of the source code, are
Yeah.
part of the instruction
Yeah.
that you give to your model.
Okay.
So a carefully curated data set will help you build a good model. Now, this is a challenge. We see many organizations that underplay or underestimate this factor. We've seen projects starting saying that we're going to use Agile, we're going to use Java, Python, all these technologies. And when this question like is, okay, what about the data? You usually get some responses like, we will see about the data, we will find the data
Mm,
later in the process. And
Bill.
we want to convince them that we try to convince them you need to take care of it from day one of your project. You need to know where you will find your data, how credible the data sources are, how are you going to make the data sets, how are you going to clean the data. And it is a project in parallel for building an AI system, not just the code, not just the model. The data itself is critical for the success of the project.
Point taken. So let's quickly pivot to not building AI systems, but using AI to build software, which is probably
Right.
far more common use case. Either you allow it in your organization or you don't, and it happens anyway. Now, all developers use to some degree these Gen AI coding assistant. What are the biggest pitfalls you think organizations need to be aware of when it comes to AI assisted code development?
Let's say the first that comes to my mind, because it's an AI, right? Over reliance. So whatever the copilot, the model creates, we blindly accept it because we don't have experience, because we want to show to our colleagues that we built something. So that's the first. The second is that let's not forget that these models, they've been trained by people, right? And been trained on source code written by people. So inherently, there will be some technical depth there. There will be security flows. And eventually, the generated code might have issues when it comes to its maintainability or its security.
Yeah.
So, and the third is, of course, the intellectual property. We've seen cases, or we heard about cases in the news that generated code was actually resembled code that was protected. It wasn't just an open source project or something like that. So these are the three things that an organization needs to have in mind. Of course, the first two are more relevant for the engineers because
Yeah.
they have more direct control to it.
So a common use case for developers is to have coding assistants in their editor. So as they're typing code,
Right.
there's a prompt and they say, can you make this function better? Or can you... And now we know, I think it was not hypothetical, is that there's a large degree of security vulnerabilities, performance issues, for the simple reason, as you say, that these LLMs are trained on market average code. So you get market average,
Right.
which is fine, as long as you check it. But isn't this solved in the future by just more modern LLMs? Maybe even in an agentic way that you generate some code and another LLM talks to yet another LLM and they keep discussing this with each other until you get to a piece of code that's actually not full of vulnerabilities. Do you think that's a possibility?
Well, everything is possible, but I would say let's be realistic here. It's like who trains the trainer? So who evaluates the evaluator? So even if we build an agent to evaluate the code, under which criteria? Who defined those criteria?
Mm,
How these criteria will be measured or implemented, and how we are certain that these are the proper criteria.
yeah,
So again, we go back to the human in the loop principle, or the fact that all agents or LLMs have been constructed by humans. It's easy to forget about it because all these tools seem magical. They make,
yeah,
but
they do.
we shall not forget these are software artifacts, right? Somebody designed them, somebody built them. They didn't come out of the blue. The other important thing when it comes to this kind of tooling is we've had cases that organizations are letting go people, and then after 2 or 3 months, the, the technical depth of the code is piling up at scale, and then they need to rehire people to take care of this technical debt. So what we see is that the profession is changing. The way software engineers work is changing and will be changing, but the skills needed will also change. So we need people with critical thinking, with review skills, that they think they see the bigger picture. So we see that the market needs this kind of skills and not just the coding skills of the past.
Oh, yes, I think the two things that I note in what you say is indeed it's very important that people keep looking at what comes out and have the skills to understand how to review code that's being written by an LLM. And I do think that there's a place for deterministic tooling where if two LLMs converse with each other, they will really agree as they typically agree. And they're very friendly. You know, apologies, and here's the right.
My best friend is an LLM. I mean, my best advisor. It agrees always with me, and it gives me the best arguments
There you
for
go,
these
but it's not
agreements. Yes.
necessarily free of problems, right? So it's very important that you have tooling in place that actually understands software risk, that is not an LLM, that it predictably gives you an outcome on security vulnerabilities, on resiliency, on performance, on cloud natives, all these things that really matter for businesses, because else you cannot rely. When you go really fast, there's a high productivity, but there's also a very high chance, a greatly increased chance of risk. I want to draw a little bit from your practical experience. Can you share a real world example of AI adoption in the telco that you saw up close?
Yeah, I mean, we've seen right now a couple of cases. One is traditional deep learning, and especially in marketing departments. And why is that? The nature of, as I said, data is socially constructed, and the nature of data is changing. So 10 years ago, organizations were collecting very transactional data but right now, with all these digital payments using cards, all the integrations with open banking, they give them more behavioral data.
Yeah.
So in order to, let's say, build better client profiles, you need better AI systems compared to the AI systems like 10 or 15 years ago, or to the rules engines they were having. So, and we see these suites, they don't do the leapfrogging. They don't go for a simple business rules engine to Gen AI. They want something which is more controllable, will give them the ability to handle more complex data, but still they feel at ease with it. So they go mostly to tradition, to deep learning. We also see cases that Gen AI is adopted mainly for internal process transformation. One example like that was this manual for network engineers to be able to have access to several sources of information for the antennas, for the infrastructure that they need to maintain. And this is also a good case of a nicely selected use case, a nice implementation, concrete results.
Mm.
So these are the two cases that we've seen. And also right now we've seen that organizations, they want to streamline more processes like phone call agents, how they handle calls, how they address the clients, what is the client experience there. We also see some new areas that organizations are experimenting.
Mm. I want to be as practical as possible. So for people listening to us, what advice do you have for organizations that are, of course, everybody here is experimenting with AI to one degree or another. If we want those platforms that we end up using to be sustainable and scalable and secure and maintainable, where should organizations start? What is very important to also have in place that is not being talked about enough?
I think we talked, data.
Yes.
And the design of the system, and make the proper selection for the proper problem. These are the three, these are the three fundamentals for a successful project. And let's say with our team, we say we want systems to be thoughtful. And I think in the era of AI systems, thoughtfulness of the teams before they even start developing a system is critical.
And what do you think about the notion of also just treating it as software? It's not some other class of things. It is software and
No,
managed.
this is
Yeah.
exactly. It's let's say at Code for Thought we have it as in our let's say reasoning as a company.
Mhm.
This is the what we acknowledge.
Yeah.
AI systems are software systems built by people, carrying their biases, their choices, the way they communicate with the rest of the world. So we need to treat it like that. It's
Yes.
not magic. It's engineering and it's a software system. So
Yeah.
the even ISO standards like 25010 what that we use for, let's say, assessing the quality of a system,
Yes.
they have, let's say, some a couple of branches, like the ISO 25059, which is the extension of this standard. So it's not a separate standard. It's extending the existing ones. So for us, it's kind of obvious that we need to treat AI systems as software systems.
Yes. So AI engineers, data engineers, in the end, they do need to talk to the software engineers about
Exactly. But all
basic.
of them, they need to talk to the business stakeholders,
Sure. Yes.
which is even more important for
Yeah.
AI systems.
Yeah. And how do you govern this? How do you see in practice? So we talked about all these requirements that you might have from software systems, from AI systems, and we just did all this scalability, maintainability.
Right.
How do you govern this?
Yeah, I think here is in a practical way. That's the short answer. But you need to, let's say, involve a bit of more people in the process. As I said, the first thing is to make sure that you have identified the proper business problem. So that's why I say you need to be in a closed loop with the business stakeholders. That's the first, and then as let's say as an engineering department, as an IT department, you need to see, okay, what are the processes I used to follow for building a software system? How can I adapt, or extend those processes for making sure I cover also the life cycle of my AI models and the data that we use? Are we going to use model versioning, dataset versioning? Following all the good practices that exist out there, we don't need to reinvent the wheel. You just need to think how you can adapt your existing processes to incorporate for the AI systems design. Lots of consultants say that you need to have support from the higher management or from C-level. For me, this is, of course, the prerequisite, because if you don't have any support, this thing doesn't, let's say, succeed. But nevertheless, you can govern things in a concrete way, and there are KPIs you can use, there are artifacts you can measure, and you can analyze. So it's not, let's say, it's not like a black box or black magic or rocket science. You need to put the foundations in place, and then systematically you need to cater for them.
Yeah, I also think that would be my key takeaway is the key thing here is that you need data, you need facts about the systems that you're building, the systems that you're maintaining, the systems that you're expanding, to make decisions on that involves multiple, so more layers of people. It's not a magic box, the AI that they do in the corner. It's really something
No.
you should treat as software. You should manage the software, not to be surprised in a year if you have a lot of debt there, of a lot of unpredictable behavior or risk in terms of security, etc. Clear.
I mean, I don't know how much time we have, but a good example is if an organization declares that we want to be fair and we want to treat our clients fairly, then all the way down to the engineering department, your AI systems, you need to measure them for bias. Because if you don't do that, then you're not fulfilling the premise of the board of directors saying we want to treat our clients fairly.
Mm.
So this is a good example of high level to, all the way down to the ground.
I think we are.
Well,
Yes.
gentlemen, I hope this is a good time to stop. Thank you very much, Yanis and Werner. That was interesting. Thank you very much.